Hello dear students, welcome to another session of mathematics. Brilliant live classes coming back again with two new concepts today: probability, relations and functions. So we have few number of days only, that's why I've combined the two topics. And probability, yes, it's very important for MCQs. Relations and functions, not that much according to sample paper, but still we are expecting MCQs from relations and functions as well. So please ask your friends to join immediately with the YouTube link sent to you all. Share with your friends, all of you, and subscribe to our channel and get live recorded sessions of Brilliant Qatar. So let me go to the topic straight away. First question: if two events A and B, P of A and P of A by B are both 1 by 4 and P of B by A is 1 by 2, then what is the option? A and B are independent. P of A dash by B equal to 3 by 4. P of B dash by A dash is equal to 1 by 2. All of the above. So I'm just first looking at this condition. P of B by A. We all know that is P of A intersection B divided by P of A. That is given to us as 1 by 2. And from this we can easily tell P of A intersection B is equal to 1 by 2 times P of A, which is 1 by 4. Answer is 1 by 8. So P of A intersection B is 1 by 8. Now I want everybody to look at the first condition. P of A by B. P of A by B, again P of A intersection B divided by probability of B, and that is given to be as 1 by 4. So from this we can say P of B is equal to P of A intersection B, which is calculated as 1 by 8 divided by 1 by 4. So the answer is 1 by 2. Yes, so P of B is 1 by 2. We have P of A 1 by 4, P of B 1 by 2. Now let's see whether option A is correct. Option A says both are independent. That is, P of A intersection B should be the product of P of A and P of B. Let's check. P of A is 1 by 4, P of B is 1 by 2, which is definitely 1 by 8. So this option is correct. It's a correct option. But we have an option D which says all of the above. We have an option D which says all of the above. So let's try what's option B. Option B says A dash by B, which is 1 minus P of A by B. What's the probability of A complement by B? 1 minus probability of A by B, which is 1 minus 1 by 4, which is equal to 3 by 4. That is also correct. So don't go and verify. See, A and B are both correct. So straight away tick option D, all of the above. Don't waste time. Okay? Don't waste time. Option D is the answer. Okay? All of you once again very clearly understand both A and B are correct. So I don't want to waste my time verifying C also, because definitely option D would be the right answer. Okay? Fine? No, the sum of the probabilities should be 1 only if both the events are mutually exclusive. Okay, they never mention anything about that, where the intersection is 0. Probability of the intersection is 0. Get it? Going to question, and they said P of A is not 0. So I can definitely say P of A intersection B is equal to P of A. Then in this case, I may say that A intersection B is equal to A. It's 11th standard idea. A intersection B is equal to A. That simply means that A is the subset of B. A intersection B has to be A, then definitely it means that A is the subset of B. What's common between A and B? If A intersection B is taken in this case, then we can definitely say A intersection B is same as A. This happens only if A is the subset of B. So my answer is option A subset of B. Yes? All of you clear? Correct? Question 3. Given probability of A is 5 by 12, probability is B is 5 by 12, probability of A by B is 2 by 5, then what is probability of A union B? The formula for probability of A union B, all of you, is probability of A plus probability of B minus probability of A intersection B. We know A, we know probability of B, but we don't know probability of A intersection B. All of you please take this condition. What is P of A by B? It's given as 2 by 5, and the formula for A by B is A intersection B divided by probability of B. And from this, what is the probability of A intersection B? 2 by 5 multiplied with 5 by 12, which is 2 by 12. Yes? And so my answer here, 5 by 12 plus 5 by 12 minus 2 by 12. So it's 10 minus 2, 8 by 12, which is 2 by 3. Option A, 2 by 3. So I'm just focusing more on questions based on conditional probability and some basic formulas, numerical questions in probability. This is what I'm expecting for this time's MCQ. One question will be from these kind of numerical questions, formula based questions. So please focus on these kind of formulas, thorough with all the formulas. You should be thorough with all the formulas. Okay? Clear? Question 4. Probability of A is equal to 7 by 13. Probability of B is equal to 9 by 13. Probability of A intersection B is equal to 4 by 13. Then what is the probability of A complement given B? What is the probability of A complement given B? Please learn the formula. I already gave you the formula for this. Probability of A complement is 1 minus probability of A given B. Learn it. What is the formula for probability of A complement given B? 1 minus probability of A given B. Probability of A complement, 1 minus probability of A. Easy to remember. And what is probability of A given B? P of A intersection B divided by P of B. And we have A intersection B, which is 4 by 13, and we have probability of B, which is 9 by 13. So 1 minus 4 by 9, the answer is 5 by 9, option D. The answer is 5 by 9, option D. Yes, all of you please start asking doubts and start giving me the answers. Okay? Because I have to finish 2 topics, I might be moving a bit faster today, but I want everybody to start giving answers. These are numerical formulas. Most of them is going to be repeating now. So now you can start giving answers, all of you. Okay? Fine. Next, question 5. A and B are 2 events associated with a random experiment where P of A is given, P of B is given, P of A intersection B is given. The question is to find P of A intersection B complement. What is the meaning of A intersection B complement? If you want, you can start learning. This refers to only A. I want the probability of the outcome to become only A. That is actually, I want A minus A intersection B. That is, from A, I am removing whatever is a B. I want only A, so from A, remove whatever component belongs to B. Yes, so P of A is 0.3 minus P of A intersection B is 0.1. So the answer is 0.2. Yes. Right answer coming from Dhruvil. Hadia, yes. Answer is 0.2. Option C, 0.2. A intersection, B complement. When you want only A, that is the complement is going to be only on one of the sets. You take A minus A intersection B. A minus A intersection B. Question 6. Yes. Again, a new formula coming up. Learn this formula. I'm just trying to teach you all the numerical based formulas once again. It's very important to learn them because one question is going to be coming from this topic, numerical problems. Okay. P of A dash given B dash. The complement is on both the sets, on A as well as on B. Before we saw the formula for A dash given B. That's 1 minus probability of A by B. Yes, but this is the complement on both. So learn the formula. 1 minus P of A union B divided by 1 minus P of B. Please learn the formula, all of you. What is the formula for complement on both the events of a conditional probability? P of A complement given B complement. It's 1 minus P of A union B divided by 1 minus P of B. We all know what is A union B, right? It's going to be P of A plus P of B minus P of A intersection B whole divided by 1 minus P of B. All the values are given to you in the question. P of A 0.6, P of B 0.2, P of A by B is given. Before also, we saw how to calculate P of A intersection B from this. This is given as 0.5. So P of A intersection B divided by P of B equal to 0.5. So P of A intersection B is equal to 0.5 times 0.2. The answer is 0.1. Substitute that. 1 minus P of A 0.6 plus 0.2 minus 0.1 divided by 1 minus 0.2. 0.6 plus 0.2, 0.8 minus 0.1, 0.7. So 1 minus 0.7 by 1 minus 0.2. It's 0.3 by 0.8, 3 by 8. Option C, 3 by 8. Okay, very good all of you. Yes, right answers coming from Jawad, Abin, Hafiz, Dhruvil, Adil and Sana. Very good. So now everybody is now used to it. Learn this formula very well. When there is a complement on both the events, what we are supposed to do. Okay, moving forward again. Question number 7. A and B are two events such that P of B is 0.4, P of A union B is 0.6. A and B are independent as well. Come on, I already gave it. The first question, A and B are independent. It simply means what? P of A intersection B is same as the product of P of A and P of B. Very important condition for a question of numericals. Probability of A intersection B is equal to P of A into P of B. So we have to find P of A here, my dear students. I have P of B, I have P of A union B, and I have P of A intersection B as P of A into P of B. I'm supposed to find P of A here. So P of A union B, formula all of you. It's P of A plus P of B minus P of A intersection B, which is P of A into P of B. It's not always like this. Please remember, don't say sir said P of A intersection B is P of A, P of B. I'm going to apply it every time. No, it only happens if the question says they are independent. A and B are independent events, only then you can do it. Okay, fine. So substitute the values. 0.6 is equal to P of A is not known, P of B is 0.4 minus P of A I don't know again into 0.4. Okay, so bring 0.4 to the left side, you will get 0.2. P of A minus 0.4 P of A, I will say it is 0.6 P of A. 1 P of A minus 0.4 P of A is 0.6 P of A. So what is P of A? 0.2 divided by 0.6. The answer is 1 by 3. Option B, 1 by 3. Yes? Only two answers came. Prapti and Javed are the only two people. Yes, Hadia now. Answer option B. Answer option B. Learn it, all of you. I do not know what is P of A, but I am given that P of A intersection B is P of A into P of B, saying that they are independent. Only if they are independent. Keep in mind, this is something that everybody by hearts and goes and applies in every question. Don't do it. It's only if A and B are independent. Question 8. P of A is given, P of B is given as 0. What is P of A by B? P of A by B is P of A intersection B divided by P of B. P of A intersection B divided by P of B. Now, what's P of A intersection B? I don't know. But still, whatever it is, my denominator is 0. What happens if denominator is 0? It's not defined, right? Yes. P of A intersection B divided by P of B, which is 0, makes it not defined. Answer option C. Not defined. Yes, right answers coming from Hafiz, Sana, Dhruvil, Prapti, Aditi, Hadia. Yes. All of you right. Everybody is giving answers. Not defined. So again, I had to know the formula. Only then I could come to a conclusion. So please be careful. Learn the formulas. Simple questions like this are also bound to come for numerical problems. Next, they have P of A by B equal to P of B by A. Then which of the following conditions? No values, nothing. It's a condition based question. We did a question like this before. A subset of B. Remember? Yes, the same thing, same way. P of A by B equal to P of B by A. A by B means A intersection B divided by P of B. B by A means again A intersection B divided by P of A. So from this, can I not conclude that P of A is equal to P of B? And that's definitely one of the options. Option D. P of A is equal to P of B. Easy, right? Yes. So all of you, please once again try to understand simple formulas of A by B. Keep in mind how many times we applied it. There are three formulas you should keep in mind about A by B. What is the first one? The direct formula, which is A intersection B divided by P of B. The second one, the complement of A by B, which is 1 minus P of A by B, formula number 1. Now, the complement on both events A and B, it's 1 minus P of A union B divided by 1 minus P of B. If you keep these three formulas in mind, you can do any question that comes with respect to conditional probability. Numerical problems based on this is, like I could say, 95% the question is going to come from this topic, numerical problem. So please be ready with it. Moving on, question number 10. I have P of A, I have P of B, I have P of A union B. I'm supposed to find, definitely I need P of A intersection B. Yes, P of A intersection B when A union B is given as P of A plus P of B minus P of A union B. This is the addition theorem you learned in 11th standard. You just have to rearrange it. I will get P of A intersection B. It's 3 by 10 plus 2 by 5 is 4 by 10 minus 3 by 5 is 6 by 10. Answer 7 minus 6, 1 by 10. Okay, now let's find what is P of B by A plus P of A by B. Simple answer, start calculating. P of A intersection B by P of A. P of A intersection B by P of B. A intersection B calculated 1 by 10. P of A 3 by 10 plus P of A intersection B again 1 by 10. P of B is 2 by 5, which is 4 by 10. So it's actually 1 by 3 plus 1 by 4, which is 7 by 12. 7 by 12, option D. 7 by 12, option D. Okay? Right answers coming? Yes. Faris, Jawad, Sana, Prapti, Hadia, Aditi, Hanan. Yes, very good all of you. Everybody started giving answers now. So numerical problems, I think everybody is now okay with. Let's move on to questions. Again, this question is based on probability distribution. We are expecting a 3-mark question actually from this topic. I'm not going to say 1 mark is very important for this, but still I don't want to take a chance. That's why I'm putting just 2 questions based on this. The first question I'm asking is to find the mean of this given probability distribution. What is the formula to find the mean of a probability distribution where both the random variable x and the probabilities are given? It is the sum of x and p of x multiplied. Just add after multiplying x and p of x. So the first thing I'm going to do is I'm going to simply multiply x with p of x. The first answer 0, second answer 0.2, third answer 0.6, fourth answer again 0.6, and the fifth answer is 0.4. Just add it up. 0 plus 0.2 plus 0.6 plus 0.6 plus 0.4. Answer, it's going to be 1.8. Yes? What's the answer, all of you? 1.8. Option C. 1.8. Option C. Right answer, Sana, Hafiz, Shadi, Aditi, Angelan. Yes, Hadia, Dhruvil, Jawad and Faris. Very good. Very good answers, all of you. So, how to find the mean? Simple question. No complications here. Just learn how to find the mean of a probability distribution. Next, one more type is like finding the value of an unknown constant called k. And we should just know what for this. K is along the probability. According to the idea of probability distribution, the sum of the probabilities is always 1. Yes? Probability distribution says every probability distribution, the sum of the probabilities is always 1. So here I can say k plus 3k plus 3k plus k equal to 1. Add it up, you get 8k equal to 1 implies k is equal to 1 by 8. Apart from these two, I don't think a 1-mark question is going to come from probability distribution. Just finding the mean or just finding an unknown constant called k using the properties of probability distribution. So my answer, k is equal to 1 by 8. Option A. I believe everybody is clear. Yes? So many, around 10 to 12 students have given the answer, option A. Very good. Question number 13, read it properly. A person draws a card from a pack of playing cards, replaces it and shuffles the pack. He continues doing this until he draws a spade. The chance that he fails the first 2 times is. Read it properly. A person is drawing a card from a pack of playing cards, replaces it and shuffles the pack again, and he then again draws a card. He keeps on doing this until he draws a spade. The chance that he is going to fail the first 2 times. What is the meaning that he fails the first 2 times? He does not get a spade. He does not get a spade first 2 times. That's what I need. What is the probability of not getting a spade the first time? There are 39 cards which is not a spade out of 52. The second time he has replaced the card back. So the number of cards still is 52. And he is supposed to fail the second time also. Half is right answer. He is supposed to fail the second time also. So the first 2 times he failed. After that what happened? I don't know. They never said anything about what happened after that. He took the card, he failed. Again he replaced it, again he shuffled it, he took a card, he failed. He did not get the spade the first 2 times. So actual answer is 3 by 4 into 3 by 4, which is 9 by 16. Option D. Yes? Only one student gave the answer. It's a very simple idea. The story is what confuses you. So they have a habit of confusing you with the story. Don't get caught by it, okay? Don't get caught by the story. Just, it's a 1 mark MCQ. How complicated can they make it? Okay? They just said, draw 2 times, both times fail. You should not get a spade. And each time you're drawing after replacing the first draw. Got it? Right answer? Yes? Good. 14 now. There are 3 persons who are firing at a target. Starting with A, their probability of hitting the target are 0.4, 0.3, 0.2 respectively. What is the probability of 2 hits? At a time, only 2 should hit. That is, they want the probability that A is going to hit, B is going to hit, but C does not hit. Or maybe they want the probability that A is going to hit, B does not hit, C is going to hit. Or they want the probability that A does not hit, B hits and C hits. Very simple. In all these cases, one of them does not hit, the remaining 2 hits. So 2 hits. What's P of A? 0.4. What's P of B? 0.3. And what is the probability C is not going to hit? 1 minus 0.2, which is 0.8. Right? Why did I multiply? Because these are independent events. 3 persons are firing at a target and it's very clear that they are independent, right? A person hitting a target does not depend upon what the other person is doing, right? So they are independent. Or means add. A is 0.4. Complement of B is what? 1 minus 0.3, which is 0.7. 0.7. And probability of C is 0.2 plus again A complement 1 minus 0.4, which is equal to 0.6. So 0.6 into 0.3 into 0.2. Calculate this. When you add it up, you will get the answer. So 4 3s are 12, 12 8s are 96. So 0.096. 0.096. Next one, 28 2s are 56. 0.056. And 18 2s are 36. 0.036. 36, 56, 96, 188. 0.188. Option B, 0.188. Right answers from Abin, Jawad, Dhruvil and Hafiz. So, very clear answer. I want only 2 hits. So, I just consider the situation that only 2 of them are hitting the target. Question 15. A die is thrown and a card is selected at random from a deck of 52 cards. Is there any dependency between this? A die is thrown somewhere and somewhere else a card is drawn from a deck of 52 playing cards. The probability of getting an even number on the die, probability of even number on die, we know there are 3 even numbers on the die, so 3 by 6, which is definitely 1 by 2, and a spade card. So what is the probability of getting a spade card? We know there are 13 spades in a deck of 52 cards. So 13 out of 52. So answer is 1 by 4. I want both to happen and these are independent events. So what is the probability? Probability is equal to 1 by 2 into 1 by 4, which is 1 by 8. Option C. Very good. Faisal, Hafiz, Prapti, Dhruvil, Faris, Jawad. 10 to 15 already answers came. Very good. Answer is simply 1 by 8. So story could be a big one, but still the answer is going to be simple. Just have to be only multiplying. Multiply the corresponding probabilities. Independent events. 16. A flashlight has 8 batteries, out of which 3 are dead. If 2 batteries are selected without replacement and tested, the probability that both are dead. What is the probability of getting a dead battery? What is the probability of getting a dead battery? There are 3 out of 8, right? Yes. Now they're saying that 2 batteries are selected without replacement. Since it is without replacement, what happens? Probability of 2 dead batteries means that the first time you pick a dead battery and multiply. The second time also you have to pick a dead battery, but this time the problem is you are not replacing the first battery. So the number of dead batteries is now only 2 and total number of batteries is 7. So answer is 2 and 8, 4 times 3 by 28. And because it is without replacement, just reduce 1 battery from the dead batteries and 1 battery from the total number of batteries. So 3 by 8 into 2 by 7. Option D. Yes, right answer already from 10 of you. Very good. So you have the ideas. Just use it quietly and calmly in the exam. You don't have to too much think about what's happening in the question. It is MCQ. Yes, I agree there are certain questions which are confusing. It will not go. I have questions like that, 1 or 2 in this. Okay, but still you can easily think. Question number 17. This is one such question where you are going to be confused. 8 coins are tossed together. 8 coins, my dear students. The probability of getting exactly 3 heads. What is the probability of getting a head? When a coin is tossed, the probability of getting a head is 1 by 2. What is the probability of not getting a head? That simply means getting a tail. That is also 1 by 2. So now I am tossing the 8 coins, of which only 3 of them should be heads. Probability of 3 heads in 8 coins. I would say 1 by 2 raised to 3. That is 1 by 2, 1 by 2, 1 by 2. Getting a head 3 times. 1 by 2, 1 by 2, 1 by 2. And then 5 times I should not get a head. This first one talks about getting a head. And the second one talks about getting a tail. So normally this is the answer, 1 by 2 raised to 3, 1 by 2 raised to 5. But there is a very simple problem here which most of you will not think. We do not know the order in which we are getting this head and tail. That is the biggest problem here. There could be different combinations. We have to put 8C3 here. The different from 8, out of 8 coins, I have to choose 3 coins which should give me head. So it can happen in how many ways? 8C3. Understand why 8? Total number of coins. Why 3? Because I need 3 of them to be heads. Okay, fine. 8C3, 8 into 7 into 6 by 3 into 2 into 1. 1 by 2 raised to 3 is 1 by 8. 1 by 2 raised to 5 is 1 by 32. Please simplify the answer, all of you. You can see 6 and 6 goes, 8 and 8 goes. Answer is 7 by 32. All of you, answer 7 by 32. Option B, 7 by 32. Okay, Jawad, Dhruvil, yes, Adin and Faris. 7 by 32. Please remember why 8C3. Please remember why 8C3. Okay, the last question in probability. It's actually a very famous question. And please, I want everybody to listen very carefully. In a leap year, how many days? in a leap year. 366 days. Okay, I want to calculate how many weeks are going to happen here. A week has 7 days. So if I divide 366 with 7, I will get 52 times, which is 364, the remainder being 2. So in a year, I have perfect 7 weeks. In a leap year, I have perfect 52 weeks. How many weeks? 52 weeks. And then 2 days are left out. Okay, that means there are going to be perfectly 52 Sundays, Mondays, Tuesdays, Wednesdays, Thursdays, Fridays and Saturdays. 52 perfectly. The last 2 days could make 2 of the days as 53 days. 53, okay? 53 times. So that's the problem here. What is going to be those last 2 days? It could be a Sunday, Monday. Yes. These 2 days could be a Sunday, Monday, or a Monday, Tuesday, or a Tuesday, Wednesday, or a Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. There are 7 different ways these 2 days could come. Yes, now I need to know how many of them, what is the probability that there are going to be 53 Sundays or 53 Mondays. It's not and. It's not and. It could be 53 Sundays or 53 Mondays. 53 Sundays. Then this should come and this should come. These 2 combinations could give me 53 Sundays. Now, 53 Mondays. This should come or this should come. So, if I want 53 Sundays or 53 Mondays, only there are 3 chances. One is this, one is this, one is this. So, total out of 7, the probability is going to be 3 by 7. Finished. Very simple. Only 3 pairs can make 53 Sundays or 53 Mondays. Got it? So, 3 pairs out of 7 pairs. Simple answer, 3 by 7. Got it, everybody? Option B. Yes, some of you have given the answer as option B. Learn it. It's a very good question. So with this, I have finished the concept of probability. So I don't want to waste time too much on this. Let me move on to relation functions. I'll try to do as much questions as possible. Okay, so the next concept we are going to be studying is on relations and functions, and here also I've tried to include some numerical problems based on relation functions. Normal questions most of you will be able to do, but my questions are now based on some numerical problems. Listen very carefully. Okay, the first one: how many equivalence relations can be defined on a set S using the set S as A, B, C? It's a very common question that comes in the exams, and most of the times, not most, all of the times I have seen a set with 3 elements. We don't have a formula for this. Please, my dear students, we don't have a formula for this. The number of equivalence relations that can be made from this set is 5. Okay, I will write all the 5 for everybody. AA, BB, CC. This is the first and the smallest equivalence relation. Smallest equivalence relation you can make from the set. S2, again AA, BB, CC, AB, BA. When AB comes, to make it symmetric, you have to have BA. Same S3, AA, BB, CC, then I'll put a BC and a CB. Okay, again fourth equivalence relation, AA, BB, CC, I'll put an AC and a CA. Yes, the symmetric pairs included to make it equivalence. Now the last one is all of this together, AA, BB, CC, then AB, BA, BC, CB, and AC, CA. It's actually a 1 mark question, so you don't have to write and show this. You can just learn it. 5 is the number of equivalence relations that can be defined from a set with 3 elements. Number of equivalence relations, a very common question. Okay, but for your understanding, I have written all the 5 equivalence relations. Okay. Question 2. If I have a relation defined on the set A is equal to 1, 2, 3 as R equals set ordered pair 1, 2. This is not equivalence, definitely not equivalence, because it is not reflexive. To become reflexive, every element in A should have a reflexive pair called 1, 1, 2, 2, 3, 3. Not even a single reflexive pair is there. All reflexive pairs should come. Every element should have a reflexive pair. Yes, right answer is already coming from Prapti, Hafiz and Sana. It's not symmetric. Why is it not symmetric? Because I have a pair called AB, but I don't have its symmetric pair BA. So it's not symmetric. Now, not reflexive. Then the only option is transitive. But how come, sir, is it transitive? How come it is transitive? Because according to the definition, don't learn how it is transitive, then learn how it is not transitive. If I have a pair called AB, which belongs to R, and I have another pair called BC, which also belongs to R, but I do not have an AC which belongs to R. AC does not belong to R, then R is not transitive. This is the only condition where a relation cannot become transitive. I have AB, I have BC, but not AC. I have AB, but I don't have BC. This second part fails. If the second part fails, even if any one of the part fails, it's transitive. It is transitive. So this is the only condition to become not transitive. Okay, clear all of you? Question 3. Let us define a relation A greater than or equal to B. See, this is a textbook question and I want everybody to remember few textbook questions which are going to be asked in the exam. Okay, ordered pair A comma B, A less than equal to B. Ordered pair A comma B, A less than or equal to B squared. Ordered pair A comma B, A less than or equal to B cube. And ordered pair A comma B, 1 plus AB strictly greater than 0. These are 4 questions which is mentioned in the textbook with the definition. So you can by heart them, that's the best thing. For this one, it is reflexive and transitive. Reflexive and transitive, not symmetric. Okay, A less than equal to B. But here is the reverse, A greater than or equal to B, but still this holds. But still it holds. It is reflexive, it is transitive, but not symmetric. Because it will take a lot of time to prove it. Okay, but it's a textbook question, so you have to learn it. Option B, reflexive and transitive, but not symmetric. But what about the remaining? What about the remaining? Learn it please, my dear students. This is neither reflexive nor symmetric nor transitive. A less than equal to B squared is none of this. Same thing. A less than equal to B cube. Learn it. So if they ask this question in the exam, which of the following is true, you can learn this and go. It's there in the textbook, so you don't have to worry. They are expecting you to know this question from the textbook, so you don't have to prove it and show it to them. You can just learn and go. Okay, 1 plus AB is reflexive. Okay, it's reflexive, my dears. It is symmetric but not transitive. Not transitive. Learn it please. I'm saying this because it's expected. So they're going to be asking a straightforward question for MCQ. Learn it and go, tick the answer. So answer option B for question 3. Answer option B for question 3. Okay? Moving forward, all of you. Question number 4. The relation R is defined on a set A is equal to 1, 2, 3. Given by R is equal to 1, 1, 1, 2, 2, 2, 3, 3. Which of the following ordered pair should be added? I want to add an ordered pair into the relation R to make it an equivalence relation. First question, is it reflexive? Is this relation reflexive? Yes, because 1 has a reflexive pair, 2 has a reflexive pair, 3 has a reflexive pair. Now, is it symmetric? I would definitely say no, it is not symmetric. Why is it not symmetric? Because I have a pair called 1, 2. 1, 2 belongs to R. So to make it symmetric, what should I put? You have to include 2, 1 inside R. So definitely 2, 1 is my answer. So I have to put 2, 1 so that it becomes symmetric. What about transitive? Do I have a pair called AB? Yes. But do I have a pair called BC in this to verify? No. AB is there, BC, just think B and C are distinct elements, not same elements. Same elements means if it is reflexive, it is automatically transitive. Okay, so don't think about same identical elements, distinct elements B and C. We don't have anything like that. So it automatically fails the second condition to become not transitive. So it's automatically transitive. So I just want to include what? 2, 1. Just include 2, 1, then you will get it as a equivalence relation. Very good answers coming, everybody. Yes. If you take 1, 1 and 1, 3, we have a 1, 3, right? You say 1, 1 and 1, 3. Yes, but we don't have a 1, 3 here. Okay, say 1, 2. We have 1, 1 and 1, 2. We still got a 1, 2 here. Isn't it transitive then? Okay, next. The number of reflexive relations defined on a set A with 4 elements. Number of reflexive relations defined on a set A with 4 elements. Learn the formula for number of reflexive relations. All of you learn the formulas. Number of reflexive relations is equal to 2 raised to n into n minus 1. What is the formula for number of reflexive relations? 2 raised to n into n minus 1. N represents the number of elements. N represents the number of elements, which is 4. A has 4 elements, then how many reflexive relations can be made with A? 2 raised to 4 into 3, which is 2 raised to 12, which is 4096. Option D, 4096. Number of reflexive relations, all of you, 2 raised to n into n minus 1. Question 6. Number of symmetric relations. Again, learn the formula. Number of symmetric relations. Number of symmetric relations is equal to 2 raised to n into n plus 1 by 2. 2 raised to n into n plus 1 by 2. Here again, what is n? I'm using the same number. N is equal to 4. N is equal to 4. Substitute it. 2 raised to 4 into 5 by 2. 2 raised to 10. 1024. 2 raised to 10. 1024. Option A, 1024. Very good. All of you? Learn once again, what's the formula for number of reflexive relations? 2 raised to n into n minus 1. What is the formula for number of symmetric relations? 2 raised to n into n plus 1 by 2. There is no formula for number of transitive relations, don't worry. Okay, so only 2 formulas: number of reflexive relations, number of symmetric relations. Next one, number of 1-1 mappings. 1-1 mappings means injective functions. How many injective functions can be made? Always we talk about 2 sets A and B. And let us assume that the number of elements in A is m and the number of elements in B is n. And please remember, the number of 1-1 functions, is npm if m is less than or equal to n. The number of elements in the first set should be less than or equal to the number of elements in the second set. Very important. Number of elements in the first set should be less than or equal to number of elements in the second set. Otherwise, it is 0. If number of elements in the first set is greater than, like for example, here they say A has 3 elements and B has 4 elements. If it was reverse, A has 4 and B has 3. Then the number of 1-1 mappings, don't even calculate, straight answer 0. But here the answer is 4p3, which is 4 into 3 into 2. I hope everybody knows how to calculate 4p3. 4 into 3 into 2, the answer is 24. Option A, 24. Number of 1-1 mappings is NPM. NP stands for permutations, NPM, 24. Please remember, if number of elements in the first set is more than the number of elements in the second set, the number of 1-1 mappings is 0. But if it is less in the first set or equal to also is fine. Okay, then it is simply NPM. Next one, number of onto mappings. In the case of onto mappings, it's a very complicated formula, but don't go after the complicated formula. Your question will always be based on a second set which has only 2. Always. The question every time is based on 2 elements. So the formula for number of onto mappings, if B has 2 elements, because otherwise it's a very complicated formula. You are not going to get that for MCQ. Please learn the formula: 2 raised to m minus 2. 2 raised to m minus 2. So the answer is 2 raised to 4 minus 2, which is 16 minus 2. Answer is 14. Option B, 14. Yes, remember very carefully, what is the formula for number of onto mappings, my dear students? 2 raised to m minus 2. M represents the number of elements in set A. M represents the number of elements in set A. Question 9. Then what is the number of 1-1 and onto mappings? 1-1 and onto. 1-1 and onto means it simply says bijective. Number of bijective functions. What is the condition for number of bijective functions? It's always n factorial if both m and n are equal. Bijection means it should be both 1-1 and onto, and 1-1 and onto both will happen if both the sets have same number of elements. Otherwise it is 0. If m and n are not equal, it is 0. So here both the number of elements in first set, number of elements in second set, both are equal. Therefore I can say the answer is 3 factorial, which is 6. Answer option C. Answer option C. Hafiz, Abin, Sana, Dhruvil and Prapti. Correct answer. Okay, but what if any one of this, like this was 4 or maybe this was 4, yes, they are not equal, then straight away answer is 0. Learn it. This 0 option exists for this also, I forgot to say it. Remember here, the 0 option exists for this also. If number of elements in the first set is less than the number of elements in the second set. If number of elements in the first set is less than the number of elements in the second set, then number of onto mappings is equal to 0. I said that it's always going to be 2 elements in the second set, but if they change, they can change it also, no problem. N of B say 5 and N of A is 4. You might be thinking, sir, did not teach me a formula for that. No need. The second set has more elements than the first set. Then the number of onto mappings is definitely going to be 0. If they are equal, you get the answer like this, right? And number for 1, 1 is, quickly for 1, 1, the number of elements in the second set should be more than the number of elements in the first set, or equal to also is fine. So please learn the conditions, that is very important. When does it become 0? When do I have to calculate? This is what you have to learn. For onto, you have to calculate only if the second set has 2 elements. 2 raised to m minus 2. Yes, please remember the conditions. Very simple conditions, one word answers. Okay, moving forward to the next question, my dear students. Every function is a special relation and every relation is not a function. If n of a equal to 3 and n of b equal to 2, then find the number of relations from a to b which are not functions. Number of relations which are not functions. The formula is number of relations minus number of functions. Okay, number of relations is 2 raised to mn. The formula for number of relations is 2 raised to mn. Number of functions is n raised to m. M is the number of elements in the first set, n is the number of elements in the second set. 2 raised to 6 minus 2 raised to 3. 2 raised to 6 is 64. 2 raised to 3 is 8. Final answer 56. Option C, 56. Learn it, all of you. Number of relations which are not functions. 2 raised to mn minus n raised to m. 2 raised to mn, formula for number of relations. N raised to m is the number of functions. Not one, not on, simply functions. Question 11. A relation R is given by A is equal to x element of integers from 0 to 12. And the R is described as modulus A minus B, which is a multiple of 4. Then what is this? Square bracket 1 is the equivalence class of 1. Equivalence class of 1. It means all the ordered pairs with 1, which gives me a multiple of 4. I'm going to say option A because option A is 159. If I subtract 1 minus 1 with a modulus, it is 0. If I subtract 1 minus 5 with a modulus, it is 4. If I subtract 1 minus 9 with a modulus, it is 8. All of these are multiples of 4. There is no other option in here which is going to give me, or no other integers from 0 to 12 which is going to give me a multiple of 4 when subtracted with 1. So the equivalence class is always a very important question for 1 mark, where it describes the elements which can be paired with that 1 to satisfy the condition in the question, and it should also belong to the set that is given to me of all the integers from 0 to 12. Okay, next question, question number 12. Which of the following functions from integer to integer? It means my domain is also an integer and my range or codomain, my codomain is also an integer. I want to take my x as an integer. I want to get my function also as an integer. Which of the following is going to be a bijection? Bijection means it should be 1, 1 and onto, both. I will say this is not onto. This is not onto. Because y is equal to x cube says x is the cube root of y. If I put y as an integer, I will not always get x as an integer, so it's not onto. Okay? According to onto, every integer should have at least one pre-image in the domain. So if I have to get this as onto, every integer should give me an x, but here every integer does not give me an x. Next one. This answer is correct because x plus 2 is always integer. X plus 2 is always integer. If y is equal to x plus 2 implies x is y minus 2, which is always an integer. Yes? So B is correct answer. C, not onto. C is again not onto. Listen to the reason, all of you. If I put this as y is equal to 2x plus 1, x becomes y minus 1 by 2. Y minus 1 divided by 2 does not always give an integer. This one, y minus 1 is equal to x squared, x is equal to root of y minus 1. Square root of y minus 1 is not always an integer. So option C and D gone. So we have only one option which says it's an integer. Okay, fine. One last question which I feel is very important, one from trigonometry. Do you see that sin x is given to you and the function is mapping minus pi by 2 to pi by 2 up to minus 1 to 1. So this is going to be your domain and this is going to be your codomain. Minus pi by 2 to pi by 2 is all the values in the second, fourth quadrant and the fifth quadrant. That is the first quadrant. Fourth and first, where we know that sign is positive, sign is negative. So it's 1, 1 because every angle in the first quadrant gives me a positive distinct value and every angle in the fourth quadrant gives me a negative distinct value. So we have distinct values for every value in the domain, hence it is 1, 1. And why is it onto? Because the range of sin x. What is the range of sin x? We know range of sin x is minus 1 to 1, and hence we can tell that range and codomain are equal. Range and codomain are equal. If this is equal, therefore function is onto. Function becomes onto if range and codomain are equal. So the option is it's 1, 1 and onto option D. Option D, right answer from Hafiz, Dhruvil, Abin and Hadia. Okay, with this we are concluding today's classes. I've covered almost every 1 mark question from both these topics. Study properly for this. But relation function, as I said, for 1 mark, not important according to sample paper, but please be prepared with these questions. But probability, very important. Learn the numerical problems. Thank you all of you. We'll see yet again with one more session of mathematics live classes. See you again. Till then, all of you, bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.